What we're doing here is actually just putting a new name on something we've been talking about already. A Riemann sum is a way of approximating an integral. So we've done that a few different ways. The formal definition of a Riemann sum says is that an integral from a to b is approximately equal to this sum right here. So let's talk about the terminology here. If n is going from 1 to, this should be an I here. I mostly just need to say this so that when I use the term Riemann sum, you have a clue as to what I'm talking about. This is a formula here that we've used in two different ways already. This formula encompasses right rectangular approximation methods, left rectangular approximation methods. It actually also incorporates the midpoint approximation methods and really any approximation method that uses the value of a function anywhere between the left edge endpoint of the subinterval and the right endpoint of the subinterval. So what the Riemann sum says is we can divide a function up into subintervals, find the areas of rectangles that are approximated by any value of the function over those subintervals, and add them together to approximate the integral. So the only difference between this and what we've been doing, there are two main differences, is that first of all, delta x is this x sub I minus x sub I minus 1. That's the difference between the right endpoint and the left endpoint of any subinterval. This could vary. Okay, so the interval widths could vary as much as you want. The other difference is when we have a function here and we break it up, I'm just going to do two subintervals to make this easy here. I could use any point, as far as a Riemann sum is concerned, I could use any value of the function along here that I want to approximate the curve there. So I could make my rectangle a left rectangle like this. I could make it a right rectangle like this. I could make it a midpoint rectangle like this. I could make it somewhere in between like this, where I'm using this point right here, or I could use this point right here. So the Riemann sum says I can use any value in between. That's what this star is here. So x sub I star is any point between x sub I and x sub I minus 1. Okay? So Riemann sums are really just a way of breaking up integrals into subintervals and approximating that way.